I want to go over domain and range with you guys. Domain is just a description of all the x values. We always go left to right for domain because x goes this way, horizontal. For range, we go lowest to highest, so that's measuring up and down, describing up and down. It's always least to greatest, whether that's left to right or low to high. For set notation, we'll use braces like this, and the reason is this is a math abbreviation for the set of numbers or whatever the description is. So this is called set notation because of these brackets. We'll also use a vertical bar, and you can make it heavy if you want to, just to make sure that it doesn't look like a 1. And in math shorthand, this means such that. Also, we'll use an epsilon, which is, it looks like a C with a line in it. A funny looking E. It means that it's an element of, which shows that this is a member of a group, or it belongs to a set. And the last abbreviation for these is for all real numbers, instead of writing the words, we'll write an R like this. So it says double struck R, it's because there's two uprights on there. Also, when you use set notation, you need to use these inequality symbols. These both mean less than. And you can remember that because it looks like an L laying down. Also, you can make a less than with your left hand. So these are not less than, these are greater. The other thing to pay attention to with these is some of them have an equals under them and some of them don't. So if it has this line under it, half of an equal sign, then it's also equal. Here are two examples that are using set notation. This would be read, the set of all x's such that x is between -3 and 4. It can be equal to 4. That's one description. We could also say the set of all x's such that -3 is less than x is less than or equal to 4. When you have all real numbers, the way you would write that is y, the set of all y's, such that y is an element of all real numbers. Or if it was domain, you would put x's there. I gave some examples here. This is a discrete graph. And we'll start by, well, it's discrete because it's made of dots. It's scattered points. It's only points. They're not connected. We're going to make a T-chart for the points that are here, and I'll go left to right. But you don't have to go left to right, but I just want to make sure I don't skip any. This first point, well, one thing is x is left and right, and y is down to up. So we'll write the points x y. The first one is -5, -1. And then I have -3, 4, and 2, -4, and 3, 2. In set notation, we'll write the domain. This says domain. It's just really faint. Sorry. As x is represented by the set of these numbers. And you just list all the x's. -5, -3, 2, and 3. None of these numbers repeat for x's or for y's, but if you do have a number that's written twice, you only need to represent it once. So you wouldn't need to write it an additional time for the repeated one. Also, we can write the range as y is equal to the set of all the y values. And they can be written in any order, like this. And determining whether it's a function, you would look and see if all of the x values are different, and they are. So it is a function. Also, we have a graph to look at, so if you prefer to use the vertical line test, in which the vertical line through any point that's graphed would only touch one point at a time, then it passes that condition as well. We also have some continuous graphs here, and we'll write domain and range. We're just going to do set notation for this right now. One way to be sure that you're describing, sorry, I didn't get my markers out. The right thing is if you consider, well, domain is all the x's, so if I made a shadow, if I had this graph make a shadow on the x-axis, my shadow would go from -1 to 2. So x is everything in between here, in between those boundaries. When I write the domain in set notation, I'll write the set of all x's such that x is in between, and again, we're going to write these least to greatest. The smallest x is -1. The largest x is 2. And at -1, I have a closed circle. So x can also be equal to -1. At 2, I have an open circle. So x needs to be less than 2, not equal to 2. So I won't put an equal with this. We'll also describe the range. Range is from lowest to highest. So if I made a shadow on the y-axis, I could use that shadow to describe my y's from least to greatest. So I can write range as the set of all y's such that y is in between 0 and 4. At 0, this curve is solid, so y can be equal to 0. And at 4, I have an open circle, so y needs to just be less than and cannot be equal. This is a function. I have a parabola here. In set notation, well, let's figure out our points first, our boundaries. This arrow at the top means that my graph continues up and left. On this other side, I have an arrow that also points up and right. And I do have a number boundary here at 0, -3. Domain describes the graph from left to right. If I were to cast a shadow on the x-axis, it would cast a shadow on the entire x-axis if this continues to go left and continues to go right. So it's all x's. It's all real numbers. To write that in set notation, you write the set of x's such that x is an element of the set of real numbers. For y, for the range, we need to describe lowest to highest. There is a lowest. The lowest y is -3. There's no highest y. It continues to go up. So I could write the range in set notation as the set of all y's such that y is in between. Actually, it isn't in between. All the y's are bigger than 0. Also, my curve is solid, so y can be equal to 0. Sorry. And this passes the vertical line test, so it's a function. I have one more example here, and I'll make note of my arrow, which goes left and also down. And here I have an open circle at 1, 3. The domain in set notation can be written the set of all x's such that all of my x's are smaller than 1. It's 1 and then down. I write it least to greatest, but I only have one number, so I can put x and I can put 1. And then I describe my x's as being less than 1. Because this is open, it's just less than, no equals. For the range, I'll describe the y's. The y's are from lowest to highest. It just keeps going down, so there's no actual lowest number, and the highest is 3. So I can write the range as the set of y's such that y is less than 3. And since it's open at the highest point, it's only less than and not equal. This is also a function.